Hello guys. I present to you the presentation of a lecture by Professor Rui Fernandes on the theme of the GPS basic concepts. Brief history of Navstar GPS. In the 1970s, the U.S. Department of Defense developed the navigation system with time and ranging, Navstar, also known as the Global Positioning System, GPS. The first GPS satellite was launched in 1978. The system was declared fully operational in 1995. The basic principles of GPS are 4 GPS satellites, 4 bands, and 3-dimensional position and time. For example, you are completely lost. You find a friendly-looking person and ask, "Where am I?" The person says to you, "You are 378 kilometers from Dubai." i.e., you could be anywhere on this circle. So you ask another person. She says, "You are 873 kilometers away from Karachi." This is helpful if you combine this information with the Dubai information. You have 2 circles that intersect. If you know you are 378 kilometers from Dubai and 873 kilometers from Karachi, then you know you must be at one of 2 points. If a third person tells you that you are 865 kilometers from Salalah, you can figure out at which of the 2 points you are. Then you know you are in Muscat. Trilateration is a basic geometric principle that allows you to find one location if you know its distance from other, already known locations. The geometry behind this is very easy to understand in 2-dimensional space. This slide shows an example of triangulation. This slide shows the observation equation. Pseudoranging. Copies of the C/A code and P code are generated in the user's receiver. The received and generated signals are matched, a time delay delta t introduced and varied until maximum correlation is found. Carrier phase ranging. Pseudo-orange measurements are not sufficiently precise for surveying purposes. Correlate the phase of the received and generated signals, estimate the integer number of cycles between the satellite and the receiver. Biases and errors. The sources of biases and errors in GPS-derived positions or baselines can be categorized as satellite-dependent, propagation medium-dependent, or receiver-dependent. This slide shows GPS accuracy in kinematics and statics. This slide shows summary of biases and errors for carrier phase measurements. Differential positioning. The motivation: most errors are spatially correlated and can be reduced or eliminated by differencing. This slide shows summary of biases and errors for differential positioning. This slide is presented. Real-time differential GPS. Thank you for attention.